Okay, so next we're going to have John Morris talk. John is going to give a 30-minute presentation on applesauce and what have the last 2 years brought. Thanks, John.
Hey, KFest. I'm not as excited as Joe. I can't do that. That's not me. But yeah, so hope everyone's having a fantastic KFest. This has been a blast for me and trying to watch everything. As is tradition, I leave my presentation till the time the KFest is actually running and don't ever actually have time to do anything. But I actually do have slides this time. So let me open up my screen share if I can figure out how this works. Oh, like that. Okay. I hope everyone can see this. Where's my slides? Okay, applesauce. What has happened in the last 2 years? Brief rundown of me. My name's John Morris. I kind of go by Disc Blitz online and some social media stuff. It was my cracker name back in the day that nobody ever heard of because I was terrible at it. And I lived in Hawaii, so nothing could ever get out. I started programming in 1981. Got a Apple IIe in 1983, and just fell in love with programming. Spent a little over 25 years in the game industry, making tons of stuff. And now I just kind of kick back a bit and, kind of got back into Apple II stuff, maybe 5-6 years ago. And yeah, just having fun, loving the Apple II still. What is applesauce? So applesauce is more than just, the box that I sell. It's kind of a big project that I have in terms of a vision of how we could improve the situation of disk preservation for the Apple II. There was already a lot of great stuff going on, but a lot of other platforms were getting a lot more attention in terms of using higher end equipment to be able to image disks and process them and do preserving. Since the Apple II was being ignored, I decided to embark on a project to do basically the same kind of thing, but with a focus on Apple II. So part of this is that I designed a floppy drive controller that allows you to take a disk 2 drive or Unidisk or an Apple 3.5 drive and be able to connect it up to a modern computer via USB. Basically got a microcontroller running inside there along with power supplies to power the drive and stuff. And there is a protocol that I can use to basically send commands out to the applesauce to tell it to do various things with the drive, turn on the motor, step the head, read bits, write bits, stuff like that. Then there's a hunk of software that is what controls the floppy drive controller, but it also, the software is for dealing with a lot of the analysis, because part of the deal with preservation isn't necessarily, well, I have imaged all of the fluxes. A lot of solutions kind of end there of, well, we've captured the data there. The focus that I really had is what we captured correct? We have a lot of disks that are rotting away. We have a lot of disks that have errors. So how do we know that what we are imaging is what was originally put on that disk and dealing with that? So the software has this whole analysis thing, this massive, it's like 300 source files large right now, of being able to process what is on an Apple II disk, which, you know, those of you that know about copy protection and stuff on the Apple II, it is the Wild West. You can do absolute insane things with an Apple II that no other platform could achieve. Commodore 64 got close, but yeah, having a drive completely under software control led to a lot of people coming up with some very creative things. And so the software basically analyzes everything about the disk and tries to interpret structure, figure out locations of, you know, where was data actually written to the media surface, things like that. And all that stuff is, you know, even if you don't have the hardware, you can still grab the software and use it on disk images that live out there. The other part of the AppleSauce project was, you know, now that we have the ability to capture, which we're using the A2R format, which is basically for capturing, how do we actually utilize these things? You know, we have the ability for to capture the copy protection, not just, you know, the data, but actually physical structure and stuff. So part of it was coming up with this WAS file format. So I've created the A2R and the WAS formats and put those into the public domain for the community to use. So a quick timeline. So basically I started it on April Fool's Day of 2017, which seems very appropriate to me. I first presented it at KansasFest in 2017, just as kind of a little prototype. You know, look what I've been able to do so far. It was originally going to be just something where I was going to make, you know, 10 of them, 12 of them, get it out to some folks that have a lot of collections and, you know, to start imaging discs. And that was kind of going to be the whole thing. But after the presentation, there was a lot more demand for it than that. So I kind of went back to the drawing board to kind of redesign the hardware from the point of view of, okay, instead of, you know, having 10, 12 people that I can manage to, you know, help through this, I now need to make something that's going to be a lot more bulletproof and easier for people to use in order to, you know, so that we could get it out to a lot of people and have it be reliable in the field and kind of democratize this imaging of discs. So right around the KansasFest time of 2018, I released the first version of the hardware along with software. And so it's been kind of kicking in the wild since, you know, KansasFest 2 years ago. Since the release then, I've had over 50 software and firmware updates. I'm constantly working on it. It's my hobby. This definitely is not a job. I got a full-time day job. But it is a passion for me, and I think it's a willing cause to sink all my time into it the way I do. A2R. The A2R format is really about archival images. It contains raw flux timings that are what comes off the AppleSauce, so it's multiple runs at a disk so that it can check, you know, cross-check the different reads and stuff like that. They run 10, 20 megabytes in size for a 140K Apple II floppy disk. So these files are huge and for the most part useless to the average user. It also contains metadata because, you know, a part of, you know, having people image things and put them in files is you kind of lose a little bit of the context of, well, what was on the label? What was the disc name? You know, what was the publisher and authors and dates and, you know, all these bits of information that may exist on the box or on the label of the disc. It gives you somewhere to put that and be able to keep that along with the image to help us to kind of better track things and not necessarily have people need to come up with, you know, crazy file names for these things. A2R is primarily used by the AppleSauce software to create disk images. You can do all kinds of exploration with it. The spec is open. There are a couple of other bits of software that utilize the A2R format, do some pretty cool things with it. You know, it's not great for emulators because these are just kind of raw pools. You know, it's a little bit more than a single rotation, you know, so that you can figure out where the actual loop point is for a track. And so by that, you know, it's collecting all of the data that it has from the disk, which, because of things like weak bit protections and figuring out loops, it isn't, you know, it isn't really a version of the disk that you could just kind of read through and play through an emulator and have it work. Down here I got a link. That's where the specification for the A2R format lives. The other format is WAS. I designed this primarily to be able to kind of keep copy protected disks, you know, all the information that you need. It's basically, it's a bit stream of exactly what is on the disk. It can locate tracks and all over the place. You know, it has quarter track resolution and it deals with fat tracks and all kinds of crazy copy protections. You know, 99% of copy protections can be encapsulated within a WAS file. You know, but the WAS file is more than just a file format. So along with the format, I ended up creating this big specification that details for emulator folks how exactly they should deal with WAS files. How do you deal with, you know, when you're stepping between tracks, and how do you deal with weak bit protections that require random bits to be thrown, and, you know, all these various details of, you know, soft switches and how they actually interact at very low levels is all kind of contained within this WAS spec and gives something for emulator developers to be able to build against. Because, you know, once you start bringing in copy protection, it requires a much higher level of accuracy in the hardware. So this spec was kind of trying to get all that out to people. And, you know, it's worked really well. There's, you know, it's had very good adoption, you know, between MAME and Virtual2 and AppleWin and MicroMate and many other software emulators. There's also the W drive and the floppy emu, and you know, so it's the WAS file format has had what I feel is pretty good acceptance in the community. And there, down at the link here is where you could go to be able to look at the WAS spec if you want to read anything about it. It's all up there. I also want to mention Flux Capacity. So this is something that's up on the Internet Archive. There's a collection called the Flux Capacity. It currently has over 18,000 Apple II disks imaged up there. um, and it's ever growing. There's a lot of folks that are contributing to this, but it is only a small fraction of AppleSauce users. So, you AppleSauce users out there that have A2R files, we would very much like to have those. So if you're willing to share, reach out to me, reach out to Jason Scott. We're both pretty easy to find. We'd love to help be able to share this stuff. Even if you have a copy of software that you already see an A2R file exists for, we still want them. We're finding new versions of everything, new releases that we didn't know that existed, all because people are willing to submit identical stuff. So, it's really quite important. And yeah, so let's do a quick demo here. We will get rid of this. Bring up the AppleSauce software. Okay, so I'll just run through this. This is basically the main screen that deals with working with the hardware. So this is the Fast Disk Imager, which is set up to deal with unprotected disks. Here's just a straight up DOS 3.3 system master. We'll just tell it to image this, and it kind of chugs along. It used to be faster, but for safety's sake, I actually have it gathering 2 copies of every sector just to double check. The checksums that Apple used, rolling XOR really is pretty terrible in terms of making sure that your sector data is correct. It only takes 2 errant bits in there to be able to come up with the exact same thing, although you have the wrong data. So, I require double captures. It used to be able to image a disk at about 13 seconds. This is a little bit longer now. So here we got the disk in. One of the new features I've added recently is this little show catalog button. So you can always hit that and it'll actually recognize that it is a DOS 3.3 disk. There's 19 files and all files verify as good. So, it basically will automatically figure out disk structure, operating system, things like that. So I'll drop in. This is a ProDOS disk. So it's going to go through and it'll find out it's a GCR disk, Apple 6 and 2, 16 sectors. Pretty straightforward. It tries to figure out operating system at the end of the run. So it comes up that this is a ProDOS disk, 39 files. So we can hit the show catalog and it will give us a catalog of MousePaint here. With this, basically, whenever it figures out the operating system, it will contextually bring up the file formats that it can write these out to. So if you image a 13 sector disk, it won't let you try to output to a DSK or a PO. It'll be like a D13 and a WAS. So we can tell it that, hey, we want to save this as ProDOS. One of the other things that you can do is you can actually tell it to export the disk contents as a file. So let's just put in this as MousePaint, and we'll just save that. So if we look here now, we have MousePaint folder, and we have an extraction log here, which basically just has the results of everything, tells you if there are any file errors and shows you which data is bad, but it'll actually break down, and here are all of the files off of the disk extracted out for us. And we also, right here is the here's the PO file. So we can actually take the PO file and we'll try to drag it, but of course it's not going to want me to drag it right now. And we can drag it over onto like Virtual 2 and be able to boot it up. I don't think I have a mouse connected to this at all, but we'll see what it does. Welcome to MousePaint. Okay, sure, that was super fun. Okay, so, you know, does the DOS 3.3, does ProDOS. It understands Apple Pascal, CPM, you know, many other formats, and I'm continuing to take requests at formats that we should support and adding them in here. What is this disk here? Oh, this is a Pascal disk. So, but yeah, so that's basically what the Fast Imager does. You know, this one is specifically for unprotected things. Okay, and this is a Commodore 64 disk. Never mind here. Hey, Boo Commodore, or no, Boo Atari. No, we'll just let it go here. So, so yeah, you know, in the last release, I did add Atari 8-bit support. There's Commodore 64 support. It will read, so it reads FM encoding. It will read MFM encoding, so it will read one side of 360K PC disks. It'll read TRS-80 disks, other things like that. But those are just kind of little add-ons because, you know, Apple II forever and hell with the rest of them. So let's see. The next thing is our Flux Imager here. Let me just get a disk to throw in here. So the Flux Imager is basically what we use for protected disks. It steps quarter track at a time, so that's what 192 tracks per inch resolution that it's walking up. And it is pulling not bits or you know, data off of it, but it is actually returning the number of nanoseconds that exist between flux transitions on the media surface. And so it's bringing this in. It is actually mapping it out in real time to the screen as well, just so you have some feedback. You can kind of tell what the disk format is and such. You know, what the visualization is showing is the density of flux transitions within any part of the media surface. So you kind of get a good view of what is truly on the disk. You can see sectors, things like that. This is an Apple II disk that is not aligned, so you know, all your sectors basically are in a rotational pattern. Here on the side is where all your product metadata can be entered in, and you know, set up requirements and set up what the names of your disks are and things like that. So, you know, basically while it's imaging, you can provide all that info. And I'm not going to bother to go through the rest of that part there because that's boring. Disk writer. The disk writer is a simple way for you to write disks, but you guys didn't expect that. So here we have, like here, we have Wavy Navy because it's an awesome game. So we tell it to load it in, and it basically writes up that it is only writing on whole tracks. If you bring in, you know, it's capable of writing to half, quarter tracks, things like that, ignoring tracks. So let's put a blank disk in here, tell it to write it. Does a little bit of analysis to figure out what the bit cell width should be. And so as it is writing, it is formatting each track as it goes. It is writing the data there, and then it is verifying the data as well. So, you know, it's kind of like what ADT Pro does, except it does everything in one step and easily, pretty quickly gets it taken care of. So it's a great tool if you have images and you need to actually write disks. Works really well for that. Then I have diagnostics. You know, have the usual, you know, disk speed test. You can run this. And the interesting thing about this is the drive is actually empty right now, because this is actually doing a speed test based on the sync sensor that is actually installed in the drive. But if you had a drive that you did not have a sensor installed, if you put in a scratch disk, it will calculate the speed for you. So this is really handy if you need to have a drive and, you know, tune it up, get it ready for using on your Apple II. You can actually do it all from AppleSauce.
5 minutes, John.
Okay, 5 minutes. Okay. So let's see. There's other things there, but let's dive in and look at some of the analysis bits of this. So we're going to bring in Ultima One. Ultima One is a great game. This is the disk analyzer here, so it's currently bringing it in and trying to process. It is trying to figure out how the disk is structured, what everything looks like, what the operating system is. This last step there, it was actually looking at the multiple reads to verify that the contents are actually all correct. So this came up all clean. It has a couple of notes here. One of the notes is that there's an embedded sector, which is basically, this is a 13 sector disk, but it does have an additional 16 sector boot. And it's telling us that the DOS is using a non-standard catalog location of track 14 instead of track 11. So this is a regular nibble view. You know, you'll recognize this. You can also set it to be like physical sectors. Here's the D5AA B5, since it's a 13 sector disk. But interestingly, if you come in and start looking at other sectors, you'll see that the prologues and epilogues are changing for every track, because they actually are rotating track markers as part of their protection. But AppleSauce figured out that they were doing that and doesn't care. Another thing that it does is, so it realizes DOS 3.2 found an actual catalog there, and it's able to actually show us what is here. I also have file viewers, so you can actually double click things. This is AppleSoft Basic, so it'll actually detokenize the basic program for you. You can also look at things in hex view and stuff like that. But this is pulling the AppleSoft Basic programs, detokenizing them from a disk that is still copy protected. AppleSauce just understands what the copy protection is now, and that is, you know, I never programmed it to understand what Ultima's protection was. It is all something that it did static analysis and has some funky machine learning bits in here to decipher what is going on and figure it out. So yeah, here's Ultima's source code. Fun. Yeah, so that's kind of the gist of it. There's a ton more features of showing, you know, all kinds of analysis of the drives and where it found tracks on the media surface and things. But that's kind of a quick run through of where AppleSauce is right now. Any questions?
Boy, we sure do have a lot of questions. Most of them are going to have to go over into the forum. But
Okay.
let's see. One of them is about does it do flux averaging for you on bad disks?
Flux averaging? No, it won't average fluxes on bad disks. It will pull them in. It will look at individual rips, seeing if there were inserted fluxes or if it's missing data or if you had something that's dirty and then later on, the head is actually scraped stuff off. If it finds good copies of things, it can actually restitch the stream at the flux level to execute repairs, things like that. But it doesn't try to average them for repairs. It will average timings to undo motor speed fluctuations of the drive itself, but it's not something it does for repair work.
Thanks, and I'm sorry we're out of time, but thanks, John.